Today I'm going to talk a little bit about the vision sensor from Festo, SBSC. So first of all, I'm going to go to the Festo website and just to show you the part number that I'm going to configure today. So the part number that I'm going to use today is the SBSC-EU-AF-R2B. Here in the support portal, you can find the software that I'm going to show, and so this will be the software Vision Sensor Configuration Studio. You can download that, and then you can also use find the technical documentation here, operating instructions and assembly instructions. So first of all, I'm going to start by getting into the software. So right now I'm connected using an Ethernet cable. One side of the Ethernet cable is RJ45 and the other side is M12. So I already configured my local area connection. So I'm on the same range 100. And actually, if you're on automatic, it should pick it up here. So again, I open up that same software, SBS, Vision Sensor Software, and it'll pick it up. But if I want to connect, it won't let me because it's in a different range. So I'm gonna change my IP address again. Oops. Okay, and now if I double click on it, I should be able to log in. Okay, so now this is the software. First of all, I want to show you the parts that I'm going to be inspecting today. So those little caps here, M12 caps, different, I have two different ones from the 5 other ones. So that's actually that's what we're looking at right now here. We have a live image. That's my hand there. First thing that I'm gonna do here, okay, I forgot to mention I'm using a backlight here. So it's a red backlight, and that will enhance the image, and it'll let me inspect the contour mainly. But in this case, I'm only gonna talk about the BLOB tool. So okay, so first thing I'm gonna set is the job here, and then you can change the name here, like for example, part count, description, you can do whatever there, and then here I can put my name. Okay, then here you can set the resolution. I'm gonna leave it at the highest resolution. Of course, I can change it to lowest, for example. That could work as well, but right now I'm gonna set it at the highest resolution. And then here we have the function of auto shutter. If you click on that, it'll auto adjust the on the software side. It'll auto adjust the brightness and some other image acquisition settings. But I can also adjust the hardware over here. So right now, for example, I'm adjusting the focus on the lens, and you can also adjust the aperture. So I'm gonna go back to there to that focus, and then here in view I can select this enlarge image view, and then that'll bring up a new screen. So here I can do fine adjustments like that. Okay, and then I can right there. So then I can close this. Then I can do an auto shutter, and then if I want, I can adjust here the shutter speed, and this will give me more brightness on the image. So I think that will work for my application. I need to get the full contour. So I go back here and then make some other fine adjustments to my focus there. All right, that seems about right. Now here, this vision sensor doesn't have internal illumination, so I can turn that off. And then the external illumination, if you switch this on or permanent, that'll enable the pin 9 on the vision sensor, and that'll you can use like an external light if you want to. The backlight that I have right now is connected directly to a 24-volt power supply. I'm not gonna use any pre-processing here, calibration none, and then you can get the cycle time over here, but I'm not gonna use that. Now I go back here to alignment, and I'm not gonna use alignment today. Detector, so here we go. The detector I wanna use today is this one, BLOB. I wanna count and evaluate the objects. So basically I wanna see that I have the 5 parts there, or 2 or whatever I need. So I'm gonna click OK. And then this is my region of interest. So I'm gonna set it to just the backlight over there, and then here. So right now it says that all of the green parts are okay. I need to make some adjustments to that. Now I don't need this help here, but I'm gonna switch to these result tabs. Then I can change the name of the detector here, so I can part counter, for example. And then this is of the type, detector type. Now here you can adjust the gray value range. So what this is about is this is from 0 to 255, 0 being darker color, and 255 being white color, right? So I'm gonna adjust it to where I get the less parts here, because I don't want to count like this. This is garbage in my analysis. Let me see, 7. So you see there's a region over here. This one is the region number 8. That doesn't count for me. So I'm gonna make some adjustments here until I start getting less and less garbage on the analysis. Since the parts are the combination of the parts and the backlight gives me a black shape, I'm gonna do an adjustment like this. Now I have 1, 2, 7 parts. Let's see. Yeah, that sounds about right. So 7 parts there. Close to 170. You can also use this function, which will pick up the color that you select. So for example, if I want to do that, it'll pick up that color and it'll auto adjust this. But in this case, it still gives me a lot of values that I don't need. So I'm just gonna leave it like the way I did it. So it was 0 to 170, and that gives me the 70 parts that I want. Now, right now, we are looking at the area in pixels for each of the parts, right? So for part number 1 and part number 2, I immediately can see that there's a difference in area between 1 and 2 and 3 through 7. So 1 and 2 are the parts that I don't want, and the rest of the parts are the ones that I want. So I can, as of now, I think that I can use that parameter to discard the ones that I don't need. First of all, the number of pieces that I need, it's gonna be, I think I have a total of 5, so I'm gonna leave it at 5. I can leave it to 5, or I can set it to 10. But in this case, I'm gonna leave it to 10. Or yeah, I leave it to 10. Now the area, as I mentioned before, I can see a difference there. So I'm gonna assume that I can safely select here anything above 30,000. So here I have 28, 27. All of the good parts are less than 30,000. So anything above 30,000 in pixels in the area, it's not something that I want to look at. So the maximum value here on the area is going to be 30,000. And that, as you can see there now, this option discards these 2 parts because these are larger than 30,000. Now I'm going to deselect here so I can continue so I can continue making adjustments here. Now, something else that I can use here is the height on an ellipse here. So height, and then I see the different heights there for the different parts that are being counted right now. And now on the second column here, I can see that the height between part 1 and 2 is different than the other ones. Now, I will have, of course, I will have to test with different settings, different orientations, and so and so. But for now, I'm going to assume that these parts are not going to be more or larger than 195 in height. So again, I can set the maximum to 195. And and then the minimum, you can set a minimum here if you want to. Let's say that I don't want it to be less than 170. And you'll see here, you can also make adjustments here with the bars. So again, 170 and no more than 195. Okay. Then you can also add more parameters here. You can play with this and see if you get the desired results. But as of now, I think that I'm good with this just to show you how this blob tool works or blob detector works. Um, Something that I forgot to mention here, if I go back to job, right now I'm on a free run, so the sensor is constantly acquiring images. If I do trigger, if I select the trigger mode, then I will have to trigger each time. And this will be the case if you have this sensor installed on a machine, you wanted to send the trigger using an output from the PLC, you can do that there and then you can configure that later on. For this example, I'm going to set it to free run. But if you want to use the trigger and then go to IO mapping, here you should have a trigger somewhere. So hardware trigger, this will be the one. So this is an input trigger, and then this is the pin number 3, color white. So using this input, you will send the trigger signal from your PLC. Gonna go back to free run. What else? What else am I missing here? I already have the height checked, the E1 height checked too. So let's test it. Output, as I mentioned here, you can do the I/O mapping, digital output interface. You can do Ethernet IP, Profinet, Ethernet, etc. Right? You have more options here that I'm not gonna mention or touch on this video. And then you can go to result, and you can basically see the table that I was looking at before. And then finally, you start the sensor. Once you start the sensor, it'll download the program that we made. It'll download it to the sensor. So if I just close, I can just close the software now, or I can save my parameter, my program. I can save it on my computer. But if I just start the sensor and I close the program, it'll automatically downloads the program. So right now the sensor is running. If I log back in, it'll put it on stop, but my program is still there. So the analysis and all of the features that I selected are still there. So let me show you how this works. Now, if I remove, for example, one of these parts, let me show you the result here. So now it says that I just have 4 good parts. I'm going to remove another one. And then I have 3. I'm going to remove all of them and leave the bad ones, and I have 0, right? But I still have parts there. But those 2 are not within the parameters that I'm looking for. So I can start putting parts here, and I gotta make sure that these parts are within my field of view, or not my field of view, my region of interest. Because if I put a part, like for example, all the way up there, it's not within the region of interest, so it will not be analyzed. Okay, so 5 parts, and then I can also remove like one of the bad ones and still 5 parts. Okay, so as you can see, the arrangement of the parts um, doesn't matter. The orientation doesn't matter because it's analyzing the grayscale of each of the parts on pixels. It's analyzing the area. I have one here. Well, that's about one. So there are 5 parts.